So the next presentation will be by Karishma Punwani and myself. Karishma, did you want to start?
Yeah, I will. Hopefully everybody can see my screen. Actually, let me pause for 1 second. Let me share the other screen. Here we go. Hopefully this is better. Oh, and that is not showing up well. Thank you, Eric. Thanks, Paul. That was a really interesting talk. Hello, everyone. My name is Karishma Punwani. I'm the Director of Academic Product Management, and along with Eric. Eric, I'll let you introduce yourself.
Yeah, my name is Eric Postma. I am the manager of the mathematical software group here at Maplesoft.
Yeah, the two of us are going to kind of start where Laurent left off and really talk about how we are leveraging AI in all of our different tools at Maplesoft. So I'm going to start this presentation, and the first thing I wanted to do is show you how we're making use of AI in our Maple Calculator tool, as well as Maple Learn, and then with Maple, and then Eric will take a deeper dive into some of the things that we're doing in Maple. So at this point, I am going to stop sharing this, and hopefully, if this works, you will now be able to see my phone. And so over here, you see I'm using the Maple calculator, and I have a word problem. So Laurent mentioned this in his talk, that the Maple calculator now has support for using an LLM to give you solutions to a word problem. So I'm going to scan this. And you can see my handwriting is not the best. And let's see how we do. So I'm just going to click on this. And it takes a moment. So you'll see there's the problem. And here it will go ahead and give me the solution. So something else I could have done as well is I could have taken a picture of the word problem, the solution. I could have brought the solution into Maple Learn, and I can have analyzed that, and I'll show you that tomorrow. But today I wanted to show you how we're taking advantage of AI in the Maple calculator in order to help students solve math word problems, because we know that's where a lot of students struggle. And to just reiterate what Laurent said in his talk, one of the goals here is to really just help students if they're struggling with, if they have some math anxiety, if they're struggling with math, if they're working on their problems at 2 a.m, just give them some support, some insight into how to do it. And what I really like is here, it understands my handwritten writing, and it doesn't have to be very nice. So at this point, I want to show you some of the things that we've done in Maple Learn. So hopefully you can see my screen now. So in Maple Learn, you can also talk to a large language model. So here I have this word problem. So finding the equation of a tangent at 0,2 to the circle with the equation, and here's the equation. Now you'll notice in Maple Learn, when I have a problem, there's going to be something over here called Ask AI. And so just for the sake of time, because I know Eric and I have a lot to cover, I pushed this prior to the meeting, but I wanted to show you the result. So here is the result that I got. And a few things that I really liked is, so we are doing some processing behind the scenes, just in terms of how the result appears in Maple Learn. So you'll see that math is live in Maple Learn. I actually got a plot over here. I can make that a little bit bigger. I can view that. So here I have my circle, and I can see my line. I can zoom in, and it goes on to explain how it calculated this particular tangent line. The other example that I wanted to show you, I'm going to close this, is Laurent talked about modeling problems. And I like this as well for helping students with modeling problems. So here you have another problem, and it asks the student, I'll read it to you. A particle moves along the coordinate axis in the positive direction to the right. Its position at time t is given by this equation. Find V1 and A1 and use the values to answer the following questions. And here are the questions, and here's the result. And again, same thing. All of the math is live. If I ever wanted to do something with the context panel in Maple Learn, I'll expand that so you can see. I could do that. Any 2D plots are automatically shown in the plot view. And so then it goes along and it actually answers the question and explains the justification. So if a student is struggling, is able to do the math, but maybe is not able to reason out the answer to those questions, they're able to use a large LLM to help them with that. And so I want to now show you what we've done in Maple 2024. So here's Maple 2024. And a few things that we've done is introduce the AI assistant palettes, the AI formula assistant palette. So this is really nice. And Eric will talk in more details about this. But here I can go ahead and I can highlight this. And I can enter it here. And so now I'm looking for the volume of a cone in terms of pi. And so I can search. And it'll go ahead and it'll give me the volume of the cone, or it'll give me the volume in terms of, or it'll give me the radius in terms of the volume and the height in terms of the volume and radius, so on and so forth. So I want the first one here. And as soon as I put my cursor, let me make this a little bit bigger. I can go and just insert the formula. And so we'll have it. And now I could always go to the context panel. And if I wanted to, I could evaluate this. Here it pops up. I'll go ahead and evaluate this at 4 centimeters and at 3 centimeters. And I can have the result. Similarly here, I can do the same thing. It asks for, we have 5 resistors, they're connected in parallel. What is the total resistance of the 5 resistors? And if you haven't used this, I would encourage you to use it. I've picked some simple problems over here just to illustrate how you use the AI formula assistant, but it works quite well. So here you see, it'll give me the equation for total resistance using series. I want parallel, so I can change that. Again, I can put my cursor there. And then I can use the context panel to go ahead and evaluate this. So other things that we've done is the natural language package. So we introduced the natural language package as a package that users could get a download off of Maple Primes in 2023. And we incorporated it and refined it for Maple 2024. And I wanted to show you some of the things that you could do, some of the things that I love about the natural language package. So the first one is the explain command. So what I love about this is that I can give it any equation. So let's say I have this particular expression, this equation, and I don't remember what it represents. I can click on explain. Let me load the package. And it gives me, tells me that this is Schrodinger's equation, and it gives me some explanation. If I go and I type explain more, it will give me a lot more detail. The other one is if I'm looking to, let's say, do a particular operation, or I want a particular command in Maple, I can use the get command feature. So here I'm going to ask it, how do I plot a sine, a contour plot in Maple? So sine XY. And it'll go ahead and do that. Now, here I have our contour plot. Similarly, I can use get math if I want to actually get an equation. So what is the energy stored in a flywheel? I could use this. Everything is represented in our Maple's natural math notation. And then I can also get a raw query. I can change the model over here. I'm using ChatGPT. By default, we're using GPT-4. And so this is the raw query. So I'm going to pause over here and I'm going to hand it over to Eric. And then Eric, I'll let you continue and add more details and explanation for the group.
Great. Thank you, Karishma. Let me find my worksheet to share. There we go. Okay, that should be working. Okay, so I want to talk about three parts of Maple and lift a little bit of the veil, as it were, and show a little bit of what's going on with these three items. The first one I wanted to talk about is deep learning. And this is one of the first, I would say, features where we explicitly let users work with AI. We added this in Maple 2018. And this the reason we could do this is because that's also when we added Maple's ability to connect with Python. And if you want to know more about that, then there is a talk later today. Well, I say later today, that's in the time zone where we are, given by Steve Forrest. And I would highly recommend that you take a look at that. That's the last talk in today's program, I believe. But let's focus a little bit on the deep learning package for now, specifically. What I want to do here is just give you a bit of a flavor of what it looks like to work with this package. I took an example that an example data set that we distribute with Maple. This is an open data set that exists, that we didn't gather this data. It exists on online platforms like Kaggle and the like. It is a medical data set where I don't even know exactly what the predicted outcome is, but the setup is we have for 768 people, certain things were measured. There were 8 different things that were measured or taken down. And a positive or negative outcome was registered at the end of the experiment. And what we want to do for this is take some of this data to train a model and try and predict for other data points what the outcome would be. And so I'll give you a little bit of the flavor for that. I'll zoom in a little bit on this worksheet here. Let me try and make it a bit bigger for you. There we go. Okay, so the first thing that you do in these sorts of problems is cleaning up the data, so we have many different facilities for that in Maple. Some of those are in the statistics package, and one of the things we might want to do here is just get a bit of an idea of what this data looks like. And one thing you might notice if you look at this is that the minimum value for a number of these values is, for a number of these categories, is 0. So, for example, for some of the people here, the glucose value was 0. And if you measure somebody's blood glucose, it can't really be 0. Then they're dead. Same for blood pressure and skin thickness and insulin level and BMI. And the other data points all look reasonable. So what we need to do is we need to repair this. So I won't go into the details because we don't have time for that. But we have here these 5 columns where there are these zeros that are present that we need to do something with, because otherwise whatever we want to train on this is not going to understand that. So we take these columns, and there are a few steps in which we do that. We have this fill missing command with which we fill in a missing value, and what we fill it in with is the median. So we have to compute the median of each column and then fill it in. Okay, so we do that, and now we have our new data set and it doesn't have those zeros anymore. So we can do that same 5-point summary, and the minimums now for glucose and blood pressure, etc., are not zero anymore. Great. Another trick that is often a good idea is to scale each of your columns so that they have mean 0 and a standard deviation of 1. And we can do that with this command. And now again, we can look at this summary and we see that, yeah, it looks, the medians are relatively close to 0. They're not necessarily exactly 0 because median and mean are not necessarily the same. But that's what we have. Okay, so we're done with our pre-processing. We can now split the data into 2 parts. We choose 600 rows of training data, and the rest, the remaining 178, are our test data. So we're going to use these 600 rows to come up with a model, and then we will use the remaining rows to check how well that model does. Okay, so this was all the pre-processing, and now comes the actual use of the deep learning package. What we do here is we create a model that consists of a few layers. I'm not going to go into too much detail of what this model actually does, but this is a very simple. So deep learning, in theory, means you can make models that have many of these layers. And really, the model that I've created here has only one real layer. So it's very simple. But nonetheless, we can see that we can get an okay model for this. So we've created this model using this TensorFlow library, and with this compile command, we set it up for doing the training. And we can see before we do the training, we have an accuracy of 48%. So that's worse than random choice. And now we do some training, and let's see what we get out of this. So we see that the accuracy goes up, and should get to about 80%. We don't quite get there today, but yeah, we got to 78% on the, or 79% accurate on the training data, and 76% on the validation data. So that's an okay result with relatively little effort. Yeah, I could go into much more detail about what goes on exactly, and why I made the choices for which layers I included here, but I don't want to do that. That's not the subject of this talk. I just wanted to give you a bit of a feel for what we do here. Okay, next subject I want to talk about is the AI formula assistant, which Krishma already talked about. What I want to do is, again, lift a little bit of a tip of the veil and show you what's going on underneath. Krishma showed you the nice user interface that we have for this here in the side panel. I'm going to show you the command that underlies it. So this is not a documented command. The documented interface is to use the nice graphical user interface for it, but I'll just show you what the command is that does this. So if we ask for formulas related to the non-ideal diode equation, or equations related to non-ideal diodes, we see that we get this result. And I just want to quickly show you what exactly the format is that we get back, because of what I'm going to show you next. We get a list of lists here, and each of the inner lists consists of 3 items. The first is a string, which is the name of the equation. The second is the actual equation in Maple format, and the third is the string of explanation. Right. So this is what the graphical user interface uses to populate the bits of the of what you see and what you can copy and paste and the like. And so to show you, let's first show it a little bit less detail. To show you how we get these results, I'll run the same command again after setting an info level message, just to show a little bit of what goes on behind the scenes to get this. So this is a relatively simple setup. We just have carefully worked on the queries that we sent to the LLM, and you can see what those queries are with this setup. So we ask the LLM to show us 5 equations about whatever the user entered, and then there's a lot of instructions about the format in which the results should come back, in order that we be able to parse that result. Initially, just about how the equations are labeled so that we can extract that. And then the biggest thing that we needed to work on to make this work well for our users is how to tell the LLM to represent bits of math in a way that Maple can parse and understand it. So we have that instruction. And then we actually call then behind the scenes, we extract the equations and we separate it into these 5 different equations. And then we call the LLM again. This turned out to be really important to get reliable results. And we again give it the instructions, the same instructions for how to represent Maple, how to represent math in Maple in order to get good results. Because it turns out that if you ask an LLM to give you something, it will often give you what you ask for, but not always exactly. So occasionally we get something back that does not satisfy what we ask for, and then we ask for it again, and then we get the right result most of the time. Okay, because of time, I'm gonna not go into more detail here and move on to the next section, which is a sneak peek. So what you're seeing here on my screen is actually the in development version. This is not Maple 2024. This is the in development version of Maple that will eventually hopefully be released as Maple 2025. And one feature that we have in here is a new command called generate worksheet. And in addition to a command, there's also a sort of experimental way to interface with this using components. And I wanted to show you a little bit of that. So what you can do with this is you can give it a prompt and then ask it to generate a worksheet about this. So my favorite subject to ask it about is fractals. And so this is now sent off a query to an LLM, and when it comes back, it will show us a simple document about fractals. And this is not a one-shot conversation as we had before, or rather, this is not a one-shot thing as we had with the formula assistant. This is a real conversation. So if we read this and we think, well, it talks about the Koch snowflake, but we're more interested in the well, we want to know more about that Koch snowflake. So please tell me more. We reformulate that. Please expand the snowflake. And maybe we'll also give it a bit more space. We'll make it 4 paragraphs. And now that again sends a query to the LLM, and we get a new result back. And when that arrives, well, one of the things that we're working with is, of course, this is in development. So of course, whenever you demo something, you see it going wrong. So let's try that again. I'll also mention another feature here. So by default, we instruct the large language model to take the perspective of a scientist to explain whatever the topic is. But we can also say we want this to be more from a teacher perspective, or even override it and come up with something manually. Let's see. And, so we will now hopefully see this second result. Because there is a communication with the server involved, you're never 100% certain that you get the correct outcome. But we see now we have this explanation of the Koch snowflake written from the perspective of a teacher. And we can switch back between the first and the second result, and or any further results that we want the LLM to generate, or we can open these as a new worksheet instead. Okay, we are very close to the end of our time here. If there is one very quick question, I think Karishma or I might be able to answer that.
Sure, Eric. There was one question that I thought would be best saved for discussion. Barb Forrest says regarding fractals in your generate worksheet, if we use this and a student submitted it, what would be the proper way to reference that submitted worksheet?
It's a very good question. I haven't thought about that very hard, but we probably should think about that.
Eric, if you might, I mean, my initial thought is I think we should be honest, right, about it. And that's what I'm seeing. It's they should reference that it comes from Maple, that they are using a large language model in all the academic institutions that I've been talking to, because this comes up in a lot of circles. I think each institution has its own standard, but it is a good discussion point. And maybe tomorrow in the education networking session, we can discuss it more, because it's one that we struggle with and I hear about it often, and I would also like to learn from the audience. So Barb, not quite the answer you were looking for. It's a very good question, and maybe we can chat more with the rest of the group.
Absolutely. That's a great plan.